So I built this motor up beginning this year for my nephew in Australia, who was asking about motors and how they work. And I thought actually the best thing to do would be to make him one and show him how they work. So made this one up, and it does work, but there was a few things that I did wrong with it. I have to say I didn't really research any of this, I just went ahead and did it, so kind of surprised that it worked at all. We've got some springs on here for the connections into the armature, and some brushes, or for the brushes, and magnets. Is that I was hoping to put the magnets on either side of this, but actually to get it to work I actually needed the magnets sort of on top, and because those are not really in the right place, they need to be really at an angle like that, which is not workable. So the idea is to make is to fix this, which we'll do by putting more a lot more windings on the coil, by adjusting where the contacts go. I think the contacts here that go onto the brush, actually I think that side of it works absolutely fine. And then for the actual contacts themselves, for the I don't know whether you can see that, this is solder wick, which actually works quite well for that. It's just glued on. You know, obviously for a motor, the armature and everything should be metal. Having a completely wooden cork thing doesn't exactly give me the best magnetism on there. But that's but you know, it works. It does work. So I'll fire this up and we'll hold the magnets there, and then we'll go through the process of fixing it. Right, so there you go. You can see it's working. Not particularly well. It's quite hard to get it going, and I'm having to hold the magnets at a particularly weird angle, and that's because the brushes are just not in the right place. But actually, for all intents and purposes, I'm quite pleased that works, because I really didn't put any checking into this. These magnets are extraordinarily strong, and we shouldn't need magnets this strong to get this going. In reality, motors are much more complicated than this. You get different types of motors. You get AC motors, you get DC motors, you get brushed motors like this one, you get brushless motors, and a whole stack of other different types and different sizes and different power requirements and different gearings and all sorts of things, different startup types. It really can become quite complicated. But for this, we're just going to keep it simple so that you can get an idea of how a motor works. So this is a picture of a simple motor, and I'll show you the four basic parts that a motor consists of. First of all, the armature. This is the center of the motor. It's the bit that spins, and it's the bit that has the magnetic coil, the electromagnetic coil wound around it, which is represented here in this picture. Now, this is very, very simple. In this picture, it's got a single part of the coil. In a real motor, there are hundreds of turns that make up the electromagnetic field. But just to get an idea on how the whole picture fits together, it's represented as a single turn. The commutators is where power or electricity is fed into the coil, and I'll explain more about how this works in a moment. And last but not least, the magnets. And these are static, they don't move, they surround the armature with the coil, and you'll notice that they're arranged in a sequential order, so it's north-south, north-south. So here's a brief explanation about how a motor works. I'm not going to go into too much detail about this because it's quite a big subject, and I just think I'll probably end up waffling along. I might do it as another video. We'll see as we go. But very, very simply, if we have a couple of magnets, if we have two magnets, one there and one there, and that's north and that's south. So this is a single magnet, and let's just have a center point over here. And then we have another magnet, and then we have another magnet over here, like that, with its poles, north and south. So with So what we get is an attraction between these two magnets pulling in that direction. These two poles are going to push away from each other, north and north. These two are going to attract each other, and those two will push away from each other. So if this magnet here is a fixed permanent magnet, and this one here is an electromagnet rotating around a central. Do a central bit a bit better here. Rotating around a central pivot, and this would be the armature of the motor, and this makes up the coil of the motor. Now, as the motor rotates through the first 90 degrees, the electromagnetic magnet will line up with the static magnet, the fixed magnets on either side. And it's at this stage of the rotation that we need to disconnect the power to the electromagnet in order for the momentum to continue the rotation past this point. Now, as we get to 180 degrees, we begin to have a bit of a problem. You'll notice that the poles are now the wrong way around. If we left the poles like that, the motor would begin to turn in the other direction. So at this stage, we need to swap the poles around by changing the direction of the current flowing through the coil, and therefore allowing the armature to rotate the final 180 degrees in the cycle. And this is achieved by the commutator, which is attached to the end of the coil. You'll see there's two parts of it on either side of the armature that would go through the middle of that. So as the coil is turning, so the contacts connected to the power swap sides, and as they swap sides, so it swaps polarity. So let's get back to the motor and see how we get on from here. Okay, so if we can see that, I'm going to start taking this motor apart. I'm going to put a new coil on here. I think the brushes are going to stay the same. I like the idea of using the solder wick as the commutators. So let's get a screwdriver and unscrew this. Take those off. This is just a friction fit on here, so that works out fairly well to be able to take these things apart and put them back on. Take the very sophisticated elastic bands off to keep. And I think we can just pull that off there and pull that off there. So I'm not going to reuse this wire. I'm just going to be right. Okay, let's see whether that angle works out a bit better. Problem is I can't see what it's doing, but there we go. Right, so got some copper wire. This obviously is insulated copper wire. And what I'm going to do, I'm not really sure how much to put on, but I want to put a lot more copper wire on. So I'm going to measure it. It's obviously got to make sure that I'm not hitting the bottom there, but I think I can get quite a number of 100 rounds in there. I'm going to start off on this side, leave enough out there so that we can join it. Okay, that's starting to slip off, so I'm probably reaching about as much as this can deal with. So what I'm going to do is then carry on the other side. Right, I think that's probably about even. I probably should have measured this out. I'll give this a go, and if it doesn't work, I will do it again, do it again, do it again and again. Right, let's get these on. Okay, now to put the commutators on, I'm going to put these exactly in line with these, I think. Right, so again I'm going to use solder wick as the commutator. I think that worked really well last time. So I'm going to cut a piece out. And then I'm going to use some super glue to glue them on at a better angle this time than I had them last time. So let's just see the length of this. Okay, so just attaching these and trying to make sure that it's exactly opposite and straight. One's a bit longer than the other one, but that should be all right. Here we go. I think that's a slightly better job. And then we connect that one to over there and that one to over there, and we can give it a test. And I'll do the same test without actually putting the magnets, attaching the magnets. I'm just going to hold the magnets, but what I really want to do is get the magnets on either side so that it's working properly from that side. And if I've got these in the right direction, then hold thumbs, that should be should all be correct. Alright, now I've got to get the insulation off. I do wish there was an easier way to get insulation off copper wire. I wonder, does anybody know of a better way than scraping it off? I never liked scraping it off. Bit of solder flux. Let's see whether we can get... Of course, heat will heat takes the glue off, but actually that's okay. I can re-glue that down. That's not too much of a worry. Right, let's do the same for this one. All right, and a bit more flux. Oh, there we go. That one stayed glued down. Okay, so let's just re-glue this one. There we go. So that hopefully will do a better trick now. Let's put our bits back in. Measure this for... it's come off again. I might have to think about a better way of doing this. This worked well for the last one, but there's bound to be a better way of doing it. Of course, again, I mean, this whole armature is cork and wood and things, which is really not the best way of doing. When I get my lathe sorted out, then I will make a better one, I think. But I think for a starting point, this should do the trick. So this is the useful thing about having these as sort of friction attachment here, because I can adjust. Okay, so that on there and that on there, and then we can okay, so let's have a look to see if I got this right and whether I need to redo it. I'll use the same mega strong magnets as I used before, just for the test. And switch that on. Got power coming on. So just setting up the Rigel. 3, what do we want? Is this connected? No, where is this connected? We don't want that connected. We want to make sure that's our middle one that's connected. 12 volts, 2 amps. Let's drop amperage down to 1 and switch that on. Okay, and then back down to there. And in theory, haha, working much better. Ha, that works superbly better. I'm very pleased with that. So the last part of this was putting together the magnets, and so I've created these 2 posts over here which I've bolted onto the back and put the magnets in. There's actually 3 magnets in here. There's an indent, a recess in here that allows the magnets to sit in there. So it's 1 magnet deep inside there and 2 magnets sticking out of the pillar. And that seems to do the job. It seems to work. I've got it going on a 9-volt battery. There we go. And I'm very pleased about how that works. So I'm going to pop this in the post and send it off to my nephew Sam and Juliet in Australia, and they can have a play with it. Enjoy. So I hope you liked the video, and if you did, please subscribe and leave some comments below if you feel so inclined to do. And stay tuned, and hopefully you will see a lot more videos. Thanks all. Bye.